Well, good morning, everybody, and welcome to today's webinar on Lockout Tagout Insights in the Steel Industry. My name is Jack Minix, and I'm a Consulting Services Manager at Workplace Safety and Prevention Services, and I'll be acting as today's host for this Safety Connection. Before we get started, I would like to cover a few webinar housekeeping issues. Firstly, computer audio is the best for this webinar. We recommend that you mute any other devices in order to avoid distractions. We'll be using the chat feature for all comments and questions. And your microphone will remain muted throughout this webinar, and you will not have the ability to turn your camera on. You may send questions to us at any time during the session through this chat feature. The chat can be accessed by clicking on the speech bubble icon on your screen. We will also have time for a question and answer period at the end of this presentation if you have any additional questions. You have the option to view the content of the webinar in a full screen mode. The full screen option can be accessed by selecting the ellipses or the three dots and then full screen from the menu as shown on this slide. Just a quick note about polls. We'd like to make this session as interactive as possible for you, and so we've added some poll questions throughout the session. Poll questions will appear on your screen and or in the meeting chat. If you have any technical difficulties during the presentation, please send us a message in the chat, which we will be monitoring. If you're not able to access the chat, you can send an email by responding to the meeting invite that you received from WSPS Safety Connection. And now I'd like to introduce you to today's speakers, Don McInnes and Michael Wilson. First, Don McInnes. Don McInnes is one of the Southwestern Regional Program Coordinators at the Ontario Ministry of Labour, Immigration, Training and Skills Development. Don supports occupational health and safety inspectors by acting as a subject matter expert on the application of the Ontario Occupational Health and Safety Act and the regulations. Don works provincially on a variety of committees regarding policy and procedures, Healthcare Provincial Program Advisory Committee, quality assurance programs, and issues specific to the industrial and healthcare programs at the Ministry of Labour, Immigration, Training and Skills Development. Welcome to Don.
Thank you, Jack.
And now Michael Wilson. Michael Wilson's a professional engineer and a Canadian registered safety professional. Over the past 25 years, Michael has held several engineering project management roles at manufacturing and consulting firms where his responsibilities included modernization projects and integration of machine safety principles. As part of his role as a senior consultant at WSPS, Mike acts as a mentor coach to advance WSPS's machine safety and robot expertise. Mike regularly contributes to several CSA and ISO technical committees and holds designations as a certified machinery safety expert, or CMSE, via TÜV Nord, and a functional safety engineer, or FSEng, through TÜV Rhineland. Mike, welcome to today's webinar. I'm going to hand control over to you now, but I'll be in the background monitoring. So if you'd like to check in at any time, I'll be ready to let you know if there's any questions or comments.
Excellent. Thanks for that, Jack. Good morning, everybody. Glad you could join us today for a quick webinar on Lockout Tagout insights into the steel industry. As Jack mentioned, he will be taking a good close look at that chat. So if you do have questions or comments as we move through, we'll do our best to address those and certainly have plenty of time for questions at the end. Just a quick heads up, the chat is open to everybody, so please be mindful of what you're putting in the chat. Happy to answer any questions, but just be careful. There's a few people watching this morning. So that said, let's dive straight into the slide deck here. Quick disclaimer, we do have a number of pictures within our PowerPoint this morning. We do have permission to use those images. Please keep that in mind. I will not be showing anything scary today. However, I will talk about the odd situation I've run across in my travels. Not intending to scare anybody, just want to have a healthy respect for exactly what equipment and machinery can do if hazardous energy is not controlled. Consistent with the other safety connections we've had in the past, the whole point of these ventures is to make sure that we're able to all stay in touch, either certainly in person or in this case virtually with our industry peers. It provides an opportunity to attend and get some additional insight that you might be able to take back to your workplace with the intent of exchanging best practices and other comments and issues that people might be running across in their own businesses. Ultimately, the idea is to learn, to share, and discover what is of value to you. And today, we'll be talking about hazardous energy control, lockout tagout. So before we jump in, I'm going to ask Emily, one of our moderators here, to kick off a poll. You should see a window that pops up on your screen, and I'm curious how you would rate your existing lockout practices. So you should see a window that popped up, and all you need to do is click the radio button and tell us what you think of your existing lockout tagout program. Does it need improvement? Is it just good enough? It does the job for us. Room to improve? Or is it best in class? So I'll give everybody a few minutes just to include their thoughts. When you are done filling out that poll, you can just X out of the screen, X out of the poll window itself. Don't close the webinar window. You'll have to log back in. So watching the numbers go up here, give a couple more minutes for everybody to finish their thoughts. So a couple of folks saying, yeah, we do need a little bit of help, and we're definitely going to be sharing some information today that can help you out. Just good enough. Okay, got some people there. Room to improve seems to be the majority at this point. And a few that are saying best in class, which is fantastic. So as we go through our session today, folks, our intent is that there's going to be some good details for all of you to take away. I'll give maybe another 10 seconds and then we'll move on from the poll and start off into our presentation today. So good spread. Looks like a lot of you have a good handle on hazardous energy control, your lockout practices themselves. I do see some people chiming in on the chat, which is fine as well. Folks, from time to time, there is a hiccup with various permissions on accessing the polls. So if you do find you can't access the poll, make sure you just drop a note in the chat for us. We're happy to have that. Yeah. Some bot issues I see. Thanks for bringing that up. So, okay, folks, thanks for that insight. That does help me out with respect to what you're looking to get out of today. And as always, folks, if you've got questions, happy to discuss them. If you want to share some of your successes and what might be useful for other folks on the call, happy to have that information put out there as well. Thanks for that. So our agenda today, folks, pretty straightforward. We've got 3 modules we want to take you through. First is just really easing into the subject. So what is the legislation, the standards that apply to hazardous energy control? Now, for the record, folks, you're going to hear me say HEC or hazardous energy control a number of times today. Lockout is pretty much the primary way of controlling hazardous energy. But I think especially you folks that have best in class programs, you've recognized it's not just lockout tagout. There might be other tasks where power is required. Think troubleshooting or setup in some cases. So we'll touch on that. And there might be other tasks you run into during a regular production cycle where there just needs to be intermittent access to the equipment, and you also need a way to control hazardous energy to allow people to do certain very minor tasks. We'll speak to those as well. Start off looking at legislation and standards. From there, we'll move into the contents of a hazardous energy control program, and then wrap up with some tips and tricks for an effective program as well. Once we're all done those agenda items, we'll open the floor up for questions. So to start us off, I'm sure a lot of you are familiar with the Green Book, Occupational Health and Safety Act, or OHSA. These are the legal requirements in the province of Ontario. For the purpose of our discussion today, we'll just touch on some high-level review of the Act and the regulations. In this case, the industrial regs is what we'll be speaking to today. This is the what. This is what we need to do to be into compliance. From there, I'll touch a tiny bit on the standards, and that is the how. Now, important difference between the legislation and the standards. We have to comply with the legislation. That is the requirements. However, when we look at the standard that applies to lockout tagout, it's actually seen as voluntary. It's a good practice document because it's not specifically cited from legislation. It's not enforceable as law. With that in mind, we all know that we have to do lockout when it comes to maintenance, but the legislation doesn't tell us how to achieve that. So whenever people approach us asking those types of questions, we'll provide guidance based on the standard, and that's the CSA Z460. We'll talk about that quite a bit as we move through our time together. And then I'll have another question for the group. This can be answered in the chat when we get there about when is lockout required. So let's take a look at a first few items here on the Act itself. Now, folks, I'm not going to sit here and read you the Green Book, but I think we all can appreciate that the Occupational Health and Safety Act is enabling legislation that sets out roles, responsibilities, legal authority, and general principles for workplace parties such as employers, workers, and supervisors. So when we take a look at Section 25(2), for example, an employer shall provide information and instruction and supervision to workers to protect their health and safety. And also, we have to remember that employers have that lovely general duty clause 25(2)(h), thou shalt take all reasonable precautions. Now, please appreciate, folks, I am paraphrasing some of the legislation here. As always, refer to the Act and regulations for the specific wording. When we take a look at Section 26, supervisors. Now, these are the supervisory duties, and supervisors really do have a tough job. They have to understand the requirements that the employer provides and then make sure that that comes to life. So as a supervisor, here's my job. You know, I've got to keep production up. I've got to keep an eye on everybody, make sure everyone's following the rules. And what we do find from time to time is that supervisors are, you know, in endless meetings or doing paperwork, and their fundamental role is to keep an eye on everybody in the workplace. Are we actually following the rules as set out by the employers and certainly by the legislation? So this can be a very tough position. And when we take a look at the duties of workers, well, hey, if I'm a worker, I've got to follow the rules. I got to follow the Act and regulations as well as the instruction put out by my employer. There's another key point that I always mention to folks that are workers on the floor. If you see something that's not right, say something. So from time to time, I've gone to a work site, we've had a conversation about lockout, tagout, and they're like, yeah, you know, we've noticed this is a problem, but you know, everybody knows about it, so we don't fix it. Like, no, you need to speak up, you need to share that information because there's no guarantee that the next person would catch it. From the Act itself, we get into the regulations. So I've highlighted a couple of sections there. So Section 42, right, power supply shall be locked out of service before any work is done on or near live exposed parts, installation, equipment, or conductors. Basically, control that energy before you get to work on it. And then a couple of other points around Section 74. Wind up having a lot of conversation on this one, and that's specific to any equipment that's temporarily elevated. So sometimes people get a look at this and they put it to, oh, if I'm working underneath a vehicle, then yeah, I need to block it so it doesn't fall on me. We have to remember that equipment, machinery, when the power is shut off, are there parts that might fall under their own dead weight or drift? Okay, so in those cases, they need to be blocked. The example I like to give everybody, when I first started working, I was going through for my HVAC license, and I was working in a big building downtown Toronto on an air handler. So we would lock out the electricity, that shuts off the motor to the fan. The problem is back pressure from the building causes the fan to spin the other way. So we needed to block that to keep it from spinning while we were working on it. So these are parts of the hazards and considerations we need to look at when we're examining the equipment and what we need to control. We'll talk about that in a few slides. And then of course you get into sections 75 and 76. Basically any part of a machine, you know, you got to stop the hazardous motion, then of course lock it out or take other effective precautions to make sure people are protected while they're working on that equipment. So this is all well and good. That's what we've got to do, but how do I do it, right? So I take a look at the standards. Now on the slide for the Act and regulations, I've purposely put the background in green. Those are from the Green Book, so those are requirements. The standards are in blue. So I've highlighted two documents there, one from CSA, that's the Canadian Standards Association, Z460, the Control of Hazardous Energy. So this is an entire document dedicated to essentially lockout, tagout, and other methods. So if you are interested, that particular document, the current edition is from 2020. It's available on CSA's website. The folks that create standards both at CSA and ANSI, ANSI is the American National Standards Institute, the standards are created by volunteers. Okay, so why do I mention that? You've got end users like yourselves, you've got equipment builders, you've got engineering, you've got enforcement bodies where they are actually sharing their insight and putting them into these standards. So when people ask me, how do I comply with legislation? Well, I've got a document either from CSA or from ANSI that says, you've got all these experts who are sharing their insight. Why wouldn't you use that document to help you get where you need to be? But I do want to make sure everybody takes away from this, the standards in Ontario, these two are voluntary. I only mention the one from the States because some of you might have influence from a parent organization that's based in the US. Fundamentally, both documents talk about the control of hazardous energy, and we are singing from the same song sheet. So it's not like you cross the border and all of a sudden there's different requirements. There are very similar requirements between our standards. So something to consider when we're looking at lockout tagout, the MLITSD does see a number of contraventions related to hazardous energy control. The biggest one, of course, is failure to lock out. So when I look at something like that, what comes into my mind? People might not have known what to control. They might not have known what hazards they were dealing with. Or, and I hate to say this, we do see it from time to time where it's one of those, oh, it'll just take me a second. I don't need to lock out. It's going to take me longer to get my locks and shut everything down than to actually do the job. So I just won't worry about it. That is certainly not behavior you'd want to encourage. Generic lockout programs versus machine specific. I can't tell you how many people we hear about where they say, you know what, I'm going to plop somebody in front of a computer. They're going to watch 5 slides, do a 10-question true or false test, and boom, you're authorized to do lockout. Those are very generic instructions in most cases. When you walk out onto the floor and now have to look at applying those solutions from a machine-specific standpoint, that can cause some confusion. Third bullet, instruction and supervision. No supervision, and also supervisor is unaware of the hazards. Very often, and I'm speaking from my own experience here, delivering lockout tagout training, you always get the folks that are applying the locks in the training, which is all well and good. What about the supervisors? Remember from the previous slide, the supervisors are responsible to make sure people are following the rules. If a supervisor doesn't recognize the hazards, doesn't understand what to do about those hazards, there's a question of competency there, but they certainly can't intervene if they see something, if they don't know what a correct lockout practice looks like. Okay, so that's just something to think about. Again, these contraventions, unfortunately, you see them over and over. So that's one of the reasons we decided to put together this presentation today. So another poll question. You've heard me mention the CSA Z460 standard. I just want to get a feel for how many of you have actually got a look at that standard. So again, thanks, Emily. It was good enough to bring up the poll. So really three options here. What's a Z460? I may have it somewhere, or again, those of you that have best in class programs, yeah, we've got it memorized. So just curious if you can take a few seconds and pop in a comment there, either through the poll. If you're not able to get to the poll, thanks. I see some people popping it into the chat. That's perfectly acceptable as well. Again, folks, I'm just looking for some insight where you are with this additional information to help with your hazardous energy control programs. Okay. All right. So we've got some people that have it memorized. Okay. Good to know. Good to know. You're one step ahead of me. That said, very useful document. Once again, folks, with respect to the standards, legislation says what we have to do. It does not tell us how. It's a performance-based requirement. How do I achieve it? Go to the standard. So, okay, I'm going to close off this poll. Thanks, everybody. Appreciate the insight there. Wanted to get a feel for where everybody was at before we jumped into this next slide. So that Z460, what kind of information would come out of it? So I've only highlighted parts of it here. Again, CSA Z460, current edition is 2020. If you're out surfing the internet, you might be able to find some older copies of it, like the 2003 or the 2013 versions. The way CSA presents their standards, once a new one comes out, all the previous ones are essentially null and void. There were changes between 2013 and 2020, so if you have the means, it might be a good document to get your hands on. If you do choose to find older versions on the internet, just please be wary that you might be missing some information because it is an older version. I've chosen just to highlight a few of the clauses that you'll see in the Z460. Clause 4, for example, responsibilities. Now, this is over and above legislated responsibilities. So what are we talking about here when we look at responsibilities? So it speaks to manufacturers, integrators, modifiers. Are they in fact designing equipment so that the end user can in effect use good lockout practices? And on that point, folks, when we're talking about information and details from the manufacturers, please, please, please take a look at the documentation that comes with the equipment from the manufacturer. Very often there's guidance related to lockout tagout, maybe not exact steps, but things to be wary of. Hey, when you shut off the power to this machine, there's capacitor banks that take time to discharge the energy. That is something you're going to want to work into your lockout program. Other responsibilities, so supervisory staff, upper management, are they actually buying equipment that is in fact designed for good lockout tagout practices? Other design requirements, an important element I do want to mention is that when you buy a machine, very often it's very well safeguarded. Lockout tagout can usually be pretty straightforward, but things get very tricky when we talk about troubleshooting or setup that requires power. So we can't do setup under lockout tagout in some cases. We can't feed material without power in some cases. How do we allow people to do that safely? When you're looking at new equipment and these particular tasks come up, what has the manufacturer built in to allow that to be done safely? Okay, and this is actually something that's not only discussed in the 460, but also in CSA's guarding standard, right? So I just wanted to highlight that. When we take a look at clauses 4 and 5, good information to start out with. Clause 6, and if you take anything away from today, folks, please, please, please consider using risk assessment if you aren't already. Lockout tagout is actually a means to reduce risk. And I've found in my travels that unless people understand the hazards associated with the equipment, they can't identify the hazardous energies. If you don't know the hazardous energies, you don't know what to control. So risk assessment is a key step to take in place before you actually go ahead and pick your resolutions. Something to consider. Last but not least, clause 7. If you get that 460 standard, clause 7 takes you through all the contents of a hazardous energy control program. It speaks to who should be getting what training, what are the steps you should be taking, training methods. It actually says explicitly stay away from generic lockout training. There's a lot of ways to deliver training, but don't let it be overly generic. It also talks about monitoring your program, how to audit, and how to give performance feedback. So again, legislation sets the requirements. How do we accommodate that legislation? Take a look at the standard. It's going to give you a lot of very good information on how to get where you need to be. So I was going to put in the chat right here, but my transitions don't seem to be working the way they should. When is lockout required? This is a question that often comes up. So I've got a pretty healthy list here. So obviously we look at repairs. Legislation, very clear. When we're doing maintenance, we need to be locked out. Inspections, unjamming, setting up, troubleshooting, testing, cleaning, dismantling, servicing machines, these all require lockout. So when you look at a piece of equipment, a machinery, process, do you know what work is being done on that equipment on a regular basis? What are the hazards? What are the risks? How do we control those risks? Consider this list of tasks as a starting point. We know repairs need to get done. Who's doing the repairs? What protective steps like lockout do they have in place before they get to do that work? And I also mentioned earlier some of those other tasks that you might not be going to full lockout, like a full zero energy state, getting into unjamming, setting up, and troubleshooting. Those are conditions where you might actually need power. So the question now becomes, if I have to do that task, and I want to specify, is it a have to do with power or is it nice to do it with power? If it's an absolute requirement for power, how do we protect people during that task? And when I say protect people, it's not just telling them to be careful. what engineered measures are in place to protect them while they're doing the work. So I do see a question that just popped up in here about tag out. Is it a requirement to have a tag? That's a great question. In Ontario, when we talk about lockout, tag out goes right along with it. Lockout, tag out. So the lock actually secures the equipment in an isolated state. The tag is actually a means of communication. You should have details like the name of the person that attached the lock, the date they attached it, and why they attached it. So if Jack's working on a piece of machinery and he's gone to stores to get some parts, I'm walking by, I'm trying to figure out why everything's locked out. I see the tag. Oh, Jack's working on it. He put on it today. He's changing bearings. So this work is in progress. Okay. So other points to that question, what information should be on the tag? At bare minimum, name, date, reason for lockout. You might want to include communication information. Here's my cell phone number. Here's how you get a hold of me on the walkie-talkie. Here's the channel I'm on for bigger sites. Does this need to be included with both routine and non-routine jobs? That gets into a much longer conversation. Certainly for regular maintenance, I would want to see tags in place on all of the locks, not just one lock. Non-routine jobs, that can get into other things like work permits, and we might have to take that one offline just to get some more details from you. So thank you for that question though. So as we round out module 1, some takeaways. Under legislation, under the standard, who is responsible for safety? Everybody. What kind of training does everybody get? What kind of supervision is in place? Do the supervisors know what to look for? Do they understand what the lockout procedures are? Does everyone understand the hazards? So when you look around your workplace, what tasks are being done? What hazards are people exposed to? And which tasks are an absolute requirement for lockout tagout? And don't forget to understand the information that you've already got available. Certainly the manufacturer's instructions. And again, consider taking a look at CSA Z460. It's a blueprint to a lockout tagout program. There's even a sample one in the annexes that you can start from and make your own. Okay, so Jack, I'm just going to pause there for a second to see if there's any other comments, questions that came your way.
Yeah, it looks like you have addressed the one about tagout, Mike. So
okay,
everything
great.
else, just a quick comment about somebody was asking for copy of the presentation, so that's been addressed in the chat, and I think that's it. You're good.
Okay, fantastic.
Oh, there's a new one just popped up.
Okay.
Yeah, can you give me an example for engineering control for working with power?
Okay, great question. So let's say I've got a process where I need to feed in coiled steel, or I've got to feed in some other material. And in order to feed in the lead edge, I need to have the equipment powered to draw that material into the process and get it going. Very often, people actually need to feed it by hand. So certainly there's hazards associated with that task. I'm not going to let you walk right up to the machine and stick your hand into any powered rollers or whatever equipment or process is drawing in that material. What I would typically see are things like a hold to run or two-hand controls. So hold to run, as an example, some people call it a dead man switch. So basically it would be a control. It can be handheld. It can actually be a foot pedal as well, where the equipment is actually allowed to run in enhanced safety conditions. And what do I mean by that? Slower speeds, lower torques, lower power. So the whole idea is you could execute this task and you've got that hold to run control. If something were to go wrong, and the whole premise of the hold to run control is it needs to be held in a set position. If for whatever reason you were to panic and you pull that trigger too tight or you drop it, a command would be issued to stop the equipment immediately, no matter which way you panicked. And the whole idea here is to allow that task to be done, but still provide a degree of protection. I need to preface that with it doesn't mean somebody won't get hurt. It means that any injury should be minimized. So I would always encourage people when they look at their processes, first step is, does it actually have to be done this way? Do I have to have a person in there stick their hands into machinery while it's powered? Can we change the process? Can we have robotics to feed the material into the equipment? But typically when I say an engineered control for these, set up tasks, it's a hold to run. It's, some kind of pendant or something in those enhanced conditions where it does allow someone to feed that end.
There was another follow-up there, Mike, from the
Yeah.
what about the routine jobs that we do multiple times on a day? Suppose like 10 times a day. Do we need information about the time every time they lock the machine?
Okay, so I'm going to ask you to put a pin in that one. Somebody's been reading ahead of my slides, and I promise I didn't plant that one. So those routine tasks that happen regularly, we're going to talk about that in the second module. So thanks for that, Jack.
Great, no problem. Thank you.
Okay, I kind of jumped ahead on the contents for this one in particular. When we look at the contents of our hazardous energy control program, we're going to increase description on responsibilities for everybody within our organization. So I touched on this a bit in my previous slides. So what is management responsible for? They need to make sure that program is developed, and they might designate somebody internally to do that. When they buy equipment, we buy it such that lockout tagout is in mind. We're going to make funds available to buy the hardware to do lockout tagout. We're going to ensure that people are trained. We're going to manage nonconformities. And again, they might designate other people within the organization to do this, but ultimately, the buck stops with management. When we look at increasing responsibilities, again, legislative requirements being what they are, we're talking about responsibilities that might be in your lockout program specifically. As a supervisor, hey, you're the ones that are on the floor all day. Maybe you should be participating in the development of this lockout program to make sure we're accommodating for those situations where we have these setup tasks where maybe lockout isn't a possibility because we need power. So we need to accommodate for those in our program. Apply your knowledge from the floor and ensure that folks that are getting this instruction, like we're covering everything they do as part of their day. Your safety managers and coordinators, again, maybe they're assigned the responsibility of developing the program. Maybe they're the ones that are managing the hardware. These are all elements that could be in your local lockout program. And finally, those authorized persons, right? Apply the program as you've been trained. But of course, if you find any shortcomings, speak up. Like, tell us if it's not right. We can fix it. Just let us know what has to be fixed. So again, if you go back to that CSA Z460 standard, it'll lay out some not only examples in the annex, but also speak to these elements in a little bit more detail. A very important part of any hazardous energy control program is to identify what energies you need to cover. So very often when I'm doing lockout training, I'll put this pinwheel up, and there are 8 different types of hazardous energy. Again, if you go into that CSA standard, it speaks to these in more detail. I'll take you through each one just while we're talking here this morning. The electrical hazardous energy, that is by far the most common. Hey, we've got electricity, whether it's 120, 220, 600 volts, okay? And a lot of people would think, as long as I shut off the electricity, the rest of the machine is safe. To which I would respond, well, what else are you dealing with? Okay, so just because you shut off the electricity, is there a chance there's an electrical charge in that system still? Okay, for example, think of capacitors. So is there a residual charge that will be there for some time after the main energy source is shut off? Anybody that's authorized to lock out that machine, they need to be aware of that. We have seen instances where people go ahead, they get started working on the machine, and they get a jolt because there was residual energy in the machine. Once again, remember from the items that the ministry identifies as common nonconformances, didn't appreciate what they were dealing with, right? So they can't take the appropriate steps to protect themselves. Another common excuse I hear, oh, we've shut off the electricity, therefore the hydraulics are safe. So hydraulics, think fluid under pressure, right? Oil under pressure. We shut off the electrical, that kills the motor, that kills the pump, no hydraulics. Not always the case, right? Is there a chance that any hydraulic pressure can get trapped in the lines, the pipes associated with that equipment? Now, keep in mind, folks, when you're talking hydraulics, we're not talking about 2, 3, 4, 5 PSI. We could be talking thousands of PSI. Okay, so I think you can all appreciate just how dangerous that would be. The common example I give to people is if you've ever tried to disconnect your garden hose at home and you get sprayed with some water, that's because there was pressure left in the hose, right? And not a lot of risk from city water, right? But if you cut into a system that's got 3, 4, 5,000 PSI, I think you could quickly appreciate just how dangerous that could be. So If we have hydraulic energies in that system, what are the right steps to take? When we shut off the electrical, the pump goes down. Does all the pressure also decrease? To that point, when we're talking about hydraulics and pneumatics, very often people rely on the gauges that are attached to the lines. Okay, power's on. I've got 1500 PSI. Awesome. Shut off the pump. Hey, I've still got 1500 PSI. And folks, something else I'd like you to take away from today, anybody working on machinery and you've identified these hazardous energies, until you know there is no energy present, you have to treat the system like there is energy in it. Okay, don't assume something is good to go. If you turn off that hydraulic system and it's still got 1500 PSI, hey, the gauge must be broken. Hold on a second. Is it possible there's still 1500 PSI in those lines? If that's the case, let's find out why. Let's find out how to drain it. And just like leftover electrical energy that's stored in the system, you can have hydraulic pressure stored in the system. How do we control that? A similar approach to pneumatics. Instead of oil under pressure, we're talking air under pressure. And folks, I know I'm using some terms that might not be familiar to you. I've been to a lot of places where I say pneumatic energy and they don't recognize what I'm talking about. Pneumatic energy, compressed air. Oh, compressed air. So again, as we're sharing the information on these programs, let's try to stick to common language that everybody would understand. For our purposes today, when I say compressed air, I'm using pneumatic interchangeably. Same issues though. We isolate the compressed air, we might have to bleed down any stored pressure. Kinetic energy. This is energy that comes from, say, a mass in motion. So think of a simple ceiling fan. When you turn off the switch on the wall, it cuts the power to the fan. Does the fan stop rotating instantly? Of course not. It's going to coast to a stop. Think about larger machinery where they might have drive shafts, flywheels. When you shut off the energy, they can still continue to move. That's kinetic energy. So here's the thing, how am I going to control that? Well, maybe a system has a braking function associated with it, and that brings the movement to a stop. Otherwise, you might just have to direct your staff to say, hey, on this machine, it takes 10 minutes to come to a complete stop. Stop the machine, let friction do its thing, let it come to a stop. Okay. Please, folks, don't ever confuse slow movement of any part of the machinery with safety. A lot of machines out there do some fantastic things. Most of them don't care if you make contact with them. And if it's moving slowly and you think it's safe, you're going to find out the hard way that that's not the fact. Okay. Potential energy. This could be a lot of things. This can be spring tension. This can be the tension associated with a coiled material. It could be gravity, right? Remember we talked earlier, the chances of things falling under their own dead weight. We need to block them if they're going to fall, or before we shut everything down, move them to their lowest point of travel. Instead of leaving a lift in the elevated position before we shut everything down, maybe we drop it to its lowest point, right? You can't fall from the bottom. But if there is a situation where somebody might have to work underneath that, then you've got to brace it solidly and securely, just like it says in the regulations, right? And I'm not talking about blocking with a 2x4 or a stone that you found somewhere. I'm talking a properly engineered device that can support that load securely. Finishing out our little pinwheel for hazardous energy here, thermal energy. That can be excess heat. It can also be the absence of heat. So thermal is a bit tricky. If something's hot, like let's say you're in a foundry or have equipment that was just shut down, it's going to be hot. You're not going to know it's hot until you brush up against it, and that's a bit of a no-no. So again, another situation where we need time. We let the equipment cool down, or if for whatever reason you can't let the equipment cool down, look at other steps to take to protect yourself, and that could be things like personal protective equipment. Radiation. So we're talking about ionizing and non-ionizing radiation, so things like X-rays, lasers, special requirements on dealing with those, but ultimately are considered a hazardous energy source. And last but not least, chemical energy. Best example I give to people is like a battery, right? Chemical reaction gives us current. So it's important that you are identifying all hazardous energy sources in the machinery inside your facilities so that people can get the right instruction on how to control them. Also, folks, don't forget things like backup systems. So I have seen a few close calls where backup generators or backup batteries kicked in for certain processes. These also need to be considered as hazardous energy and, as the case might be, take steps to control them accordingly. All right, let's talk a little bit about the isolation devices and hardware you might have as part of your lockout program. Again, you need to look at the system as if you're training somebody that's never had lockout training before. You need to walk them through those steps. They need to understand the hardware that's required to get the job done. So in image 1, pretty stock electrical disconnect. Okay, that's what DC means under that image, disconnect, with a lock in place. So what you're seeing over there, you've got that red handle that was moved down to the off position, that purple lock, and the tag was attached. Pretty standard when it comes to controlling electrical energy. Now, whenever I give training, I also talk to people about using the left-hand rule. Some people argue it's antiquated. I was taught it 25 years ago, and I've not had any close calls to speak of with electricity anyway. So if you've not heard of the left-hand rule, if you take a look at that disconnect right there, you'll see how the disconnect handle is actually on the right-hand side. So I'm convinced that these boxes were built by left-handed people trying to get back at all the right-handed people. If I were to pull that handle and I'm right-handed, I would be standing directly in front of the disconnect. Now, I don't mean to scare anybody, but it is possible that if the equipment's in disrepair, if there's a buildup of conductive dust, you might get a flash. And if that disconnect flashes and you're standing right in front of it, it's not going to be good for you. So what does the left-hand rule tell us? Even though I'm right-handed, I use my left hand. That forces me to take a step to the side. And the way I was taught was actually left hand, look away and say a little prayer. Left hand, look away, and you move from on to off position. If you happen to have a flash, you're at least standing to the side. You're still going to get injured to a certain degree, but at least you're not going to be standing right in front of it. And I would suggest for these types of disconnects, you follow the left-hand rule to actually re-engage the energy at the same time. Food for thought. I know some of my colleagues will happily share stories where people have escaped injury because they followed that left-hand rule. Moving along on our images here, we take a look at image 2. We have a hasp. Some people call this a scissor. It actually allows multiple people to attach their locks to a single isolation point. So if you look back at image 1, you'll see where the lock is placed. There's really only enough room for that lock in that particular position. If you're going to have 2 or 3 people working on that system, you would attach a hasp and then the locks go through the hasp. So the way the hasp actually works is you would place it around the isolation point, close the hasp so the 2 halves actually line up, and that'll actually attach it to the isolation point. You put your locks through there. Other equipment you might need, if you look at image number 3, we see, I call it a clamshell. What you're looking at there is a gate valve. So picture a handle very much like you'd have for your garden hose. If we need to have that valve closed, you're going to put that clamshell over top. It rotates in half, and then you can actually put it over the handle, and then you attach your lock and tag just like you're seeing in the photo. If nobody can activate the handle, then they can't open the valve, which is what you want. When you look at image 5, sometimes people say to me, "Hey, Mike, it's a 220 plug. I can't put a lock on that." Well, you've got a plug cover right there. Again, opens in half, put the plug inside, close it, lock and tag, just like you see in that photo. Now, you will note in images 2 and 6, we see 2 different types of hasps. The one in image 2 is actually an aluminum hasp. Why would you use an aluminum hasp? Maybe you're in an environment where sparking is an issue. So if you had a regular steel hasp and it happened to drop and hit the floor, could it create a spark? Well, that might be a bad thing. Aluminum won't spark. You see the one in image 6, that's a plastic hasp. I would like to identify one other item on this slide before we move on. If we take a look at image number 4, we're seeing a regular lock used as a lockout device, and I would caution you. So I get it. You go to some industrial suppliers, a quote unquote lockout lock could be $12, $14, $16. Like, that's expensive for one lock, and I get it. So somebody might say, "Hey, we go to the hardware store, we buy this regular lock you see in image 4. Couple problems with that. Number 1, the lock comes with 2, maybe 3 keys. So now you have to wonder about, what happens to those extra keys? More of a concern, in my opinion, if you go to those companies that actually sell lockout locks, There's actually provisions in the design of the lock for a greater number of key combinations. So if you buy the regular locks from the hardware store, if you happen to have a large number of those locks in use, it wouldn't take long before you can find a key that fits in a lock it didn't come with, right? So that's the difference. That's the cost difference between a regular lock, a padlock you get at the hardware store, and a true lockout lock. More combinations, less likelihood that one key is going to open a different lock. Key element of your lockout program, and again, folks, another one of those things, if you take anything away from today, please take this away. These are the 7 steps identified in that CSA lockout standard for hazardous energy control. These 7 steps apply if you're standing in front of a press, a slitting machine, a robot, a conveyor. All the steps will be there. They might not be in the exact order, but they will be there. So what are these 7 steps? First off, prepare for shutdown. Folks, if I see an incident related to lockout tagout, I can almost guarantee you part of the cause is because somebody missed something in step 1. What is step 1? It's exactly what it says, preparing for shutdown. I am going to prepare myself for that work. What machine am I working on? What energy sources do I have to control? How many locks do I need? Do I know how to control the hazardous energy? And most importantly, who do I need to talk to tell them I'm going to lock out this machine? Okay, so you're preparing for shutting down that system and getting ready to lock it out. Make sure those steps are right in your mind. Second step, pretty straightforward, shut down the machine, right? This could be as simple as pressing stop. There are cases where you might actually have to finish a cycle or get to a certain point where you want the system to be shut down. Then you go to isolate the equipment. So we're going to carefully and methodically isolate the machinery from each energy source that feeds it, electrical, pneumatic, whatever the case might be. Now that controlled stored energy step will always come into play. Depending on your system, it might be in different spots. But what do we say about energy sources? We could have leftover energy. On the electrical side, capacitors. On the hydraulic and pneumatic side, we could have pressure stored in the lines or the pipes. Okay. And I do see a question there. Are all these steps applicable to zero energy lockout or for controlled energy lockout? I'm going to get you to hold on to that. I got a couple slides more, and then we'll get right into those 2 questions. And then step 5, you're going to apply your locks and tags. So remember, we had our question on the tags: name, date, reason for lockout. Please make sure your tags are legible. I'm sure everybody is like me. You've got some handwriting that's not exactly clear. The tags should be legible. Keep in mind, folks, you might have to spend some money on tags depending on your environment. Paper tags can tear off the lock pretty easily. Some tags will have a brass reinforcement. I've also seen tags that are plasticized, right? So they cannot withstand chemicals or the environment, whatever the case might be. Please, folks, encourage your workers that are doing lockout to always verify that they're in control of the machinery. What do I mean by this? It's a very simple step: verify or die. And I have no misgivings about saying this. If you screw up lockout, there's a very real chance you could die. So let's make sure we've got the right thing locked out. So what does this look like? If I'm a machine operator and I've locked out, I apply all those steps, I go over, I try to start the machine. Nothing happened. Okay, that's great. That's exactly what I was looking for. Wait a second, is that a valid test? Why do I say this? I'm sure some of you actually have a lot of emergency stops throughout your facility, or have interlocked doors or light curtains, things of that nature. Before people test by starting the machine to validate their lockout tagout, please make sure your e-stops are reset. Make sure any interlocked doors are closed. Why am I saying this? Let's say I go to test the machine and somebody left an interlocked door open. I go to do my test. Nothing starts. Is that because the door is open, or is that because my lockout did the right thing? Okay, so there's a chance, there's a very little chance, but there is still a chance that I've got a false positive. So I always recommend check your e-stops, check your interlocked doors, make sure they're engaged, so that when I do that test, I'm going to get a valid response. Also, when it comes to your trades, so your electrical, your millwrights, they might be verifying in different ways. A millwright might go up to a valve, hydraulic or pneumatic, and try to activate it manually, try to spool that valve to see if anything happens. Electrician, be taking their meter, opening panels, checking for absence of energy. So these are also ways of verifying that you've isolated the energy source. Great point. We've noticed the contractors now using photos on their tags. Absolutely. If you want to put a picture on the tag, that's fantastic. I think that's great. At least you know exactly who owns that tag. So instead of having to write the name, you've got a picture of the person. I've seen people put pictures right on locks too. I'll talk a little bit more about step 7 in the next module, but basically one of the things we see, people get all excited about putting the equipment back into service and they forget to clean up the area. They don't reinstall the guards, things of that nature.
Hey, Mike, there was one question just before
Yeah.
that last one that you addressed about the photos,
Yeah.
asking, do we need to save the tags for record keeping?
I have seen people do it both ways. I've seen people that have a very robust permitting system, and then when the job is done, they save all the tags. I have seen people toss the tags. I would encourage you to evaluate your process and determine what works best for you. I personally am a fan of keeping the tags for archiving as a proof that the job was done. I realize not everybody operates a process that's that complex. So thanks for that, Jack. As we look at the slide here, there's a couple bits of technology that you might see. For years, it's just been put on your locks and tags and away you go. What you're looking at in the picture here is actually a photo I grabbed from a site 4 or 5 years ago now. Top center, what you see is an upstream power source indicator light. So if there's power coming to that panel, electrical energy coming to that panel, in real life, it looks lit up on the photo, but in real life, it's actually flashing. So you've got L1, L2, L3. These are the phases on your 600 volts coming into this panel. So it lights up. You can get a visual indicator that the panel is powered. On the lower left here, you see another similar visual indicator. That's for power leaving that panel. And you'll also notice in the lower right, we actually have a test port. Why is this fantastic in my opinion? Previously, if an electrician had to check for absence of energy, they would have to put on their arc flash gear, they would open up the panel. Remember what I said, until you can confirm there is no potential there is no energy, you need to treat it like there is some. So they would have to wear their arc gear, they go in with their meter and they're testing for absence of energy. This test port can allow you to do that on the electrical side from outside the panel. So it's a little bit easier to do your testing. Starting to see more and more of these pop up. It's called a PESD, which is a permanent electrical safety device. Okay, so just another way to help with verification and testing to make sure you've got absence of energy. I'm also starting to see some lockout programs that are going purely electronic, right? The locks actually have QR codes on them. So as people walk through and apply the locks, they scan the lock and everything's tracked in electronic format. Now, I've also heard, I want to stress heard, I've seen, heard about some systems from Europe where if in fact somebody abandons a lock, there are protocols in place that a Bluetooth signal to a cell phone could be used to remove the lock that was left behind. Not saying that's the best thing to do, I'm saying stuff we're starting to see. All right, other things to consider. So we talked about lockout tagout, okay, very common approach. I want to circle back to a couple of the questions where I said I'm going to come to this. Let's say you get to a very common task that happens every day, multiple times. Are we absolutely required to go to a lockout condition? I want to preface this slide with, it depends, okay? So under CSA Z460, that's the Control of Hazardous Energy Standard, and it's also in the Z432, that's CSA's guarding standard, so safeguarding of machinery. If you can determine that the task is integral to production, you may be able to use other methods. So if I go back, CSA Z460, that's the title of the document. It's called Control of Hazardous Energy, Lockout, and Other Methods. So before you can automatically say, oh, we can't do this under lock and tag, or we do this so frequently, it's a pain in the butt to do lock and tag. Hold on, okay? You see the list here. To be considered integral to production, the task has to exhibit most of these characteristics. Again, warning, most is not defined in the standard. So what does most mean to any of you? I have some people say to me, oh, Mike, most is half plus 1. So we only need to meet 5 out of the 8. If you ask me, I say 7 out of the 8. But I want you to think of your workplace, and maybe you do have a task that's integral to production. So the task is of short duration. Short is not defined. When people ask me, I tell them 60 seconds. That's short. I've seen some people try to convince me that 45 minutes is short. I disagree. Okay. The task itself is relatively minor. What does minor mean? The guidance I would typically give to somebody is that task is done without tools. And that's very specific because, in my opinion, if you are doing a task with tools, I would suggest that you're actually doing maintenance. Legislation is very clear. When we're doing maintenance repairs, we're doing lockout. So short duration, relatively minor. To the question we had in the chat earlier, the task occurs frequently during the day. Again, frequently is not determined, but if I remember from what I saw in the chat, it was something like 10 times a day. You could make an argument that that's frequent. The task is normally performed by operators, setup, or maintenance personnel. Now, I need to preface again, the reason it says maintenance personnel, in the earlier versions of this standard, it only said performed by operators. It got changed to include maintenance personnel because some facilities that we know of, I say we, I'm talking in the context of the CSA committee because I actually sit on that committee. It was brought to the committee's attention that some companies might use temporary help, and they're just absolutely forbidden to be doing anything inside the machine. So if there's a minor jam that needs to be addressed, they have to contact maintenance. So in those situations, it would be a maintenance person doing the minor task or the task that's integral to production. It's a predicted cyclical activity. That's a fancy way of saying it never changes. It's always the same. That task causes a minimal interruption to the production process. Okay, so I can pause the machine, I can safely do this task, and it's not going to cause any backups or other problems elsewhere in the system. The task is required even when things are running perfect, and task-specific training. So if you're thinking to yourself, hey, we've got some tasks that are integral to production. Okay, what does this mean? It means now you take that task, you're going to do a specific risk assessment. What are the hazards associated with that task? And you're going to run through just like you would for any other hazard. Say, okay, here's the risk. $1 million question, what are we going to do about it? So a question earlier was about controlled entry. So on some robot systems that we see, they have what they have called controlled entry or safe cell entry. So in that case, they're actually relying on the interlocks. So if somebody needs to clear a jam, they open an interlock door, they clear that minor jam. Again, no tools, very quick job, normally done by the operator, happens all the time, and boom, they do that task, close the interlock door, and restart the system. That is something that could apply to this set of circumstances. But again, you have to make sure the task is integral to production. Then you do a risk assessment and you apply engineered controls to protect the workers while they're doing that task. You don't just say, oh, we do that all the time, so we can let people go into the machine. If you're allowing that task without lockout, and again, these integral tasks wouldn't necessarily meet what I consider maintenance requirements. How are we going to protect people when they go into that system? Okay, that's really what it comes back down to. So this very quickly gets into a safeguarding discussion. But the reason I included this in our session today is so many people have blind faith in the interlocks to the point where I've been on site and people are taking equipment apart and there's no lockout. They just said, oh, well, when the doors open, everything's shut down. I said, yeah, but when the doors open, that doesn't kill all the power. It just pauses it. It's still there. If you pull the wrong lug off that motor, you're going to get a hell of a shock. You're doing maintenance. You shall be locked out. Integral to production. Oh, I need to wipe off a sensor because it got dusty. Oh, this part is misaligned on the conveyor. It got jammed up. I give it an adjustment and life goes on. Minor tasks, integral to production. Maintenance is always a lockout condition. Okay. Another useful information. Can we put a lockout on safety interlock doors considered a proper measure? Okay, good point to talk about that here. If I go back to a number of places I've been to, they have decided that that's an appropriate measure for safe entry. And if I'm reading this comment appropriately, I go right to people putting locks on an interlock door. So you're not locking out the door, you're using a lock to prevent the door from being closed. If that is the case, I have seen a lot of people do it. What would I expect to see if that were the case? That system better have been properly engineered. If it was installed within the last 20 years, it better have a pre-start. I would expect the pre-start engineer to comment on using the interlocks for that function. These integral measures, or sorry, tasks integral to production, I would expect to see some detail that, yep, we expect this to be the case. We're going to rely on this interlock. Here's how it's been properly engineered. Here's how we have trained everybody, and that's how we will allow it to happen. Why do I suggest that level of detail? I have seen people say, let's just put locks on the door and let people go in, and it's a 40-year-old machine. The way we wire safeties, the way we integrate engineered controls has changed. Okay, these older machines, their systems could be subject to failure. They may not have been properly maintained. I would have strong misgivings about allowing somebody to just enter a 40-year-old machine because it happens to have an interlock on the door. Machine or process specific lockout procedures. Want to touch on this really quickly. You heard me say earlier how generic lockout training does cause issues. It really should be machine specific. What you're seeing on the screen here is just a sample machine specific instruction. Some people call these lockout placards. Okay. A lot of different ways to lay out a placard. Okay. So what are you looking at here? Well, on the very top, what we've got is, here's our lockout procedure. Here's the machine. This just happens to be our logo. I dropped it in there just for an example. Here's a key piece of information. There are 3 isolation points. So if I'm doing step 1 of my lockout steps, preparing for shutdown, I need 3 locks. Well, if I've only got 2, I need to find another one, right? So I sign it out or get another one from my supervisor, whatever the case might be. Very important comment here. If the system cannot be locked out or if it fails verification, stop and tell your supervisor because something's not right. Right here, and I know folks, this might be a bit of an eye test for you. This is just a recant of the 7 steps that I highlighted in a few earlier slides. Some people like to use pictures. In this example, I've just used an overhead view of the machine. Here's north, right? So you see this logo right here, the blue octagon, and you can't quite see, but it's a compressed air tank, indicating that there's air pressure there. Here's where you find the isolation point. Red octagon with a lightning bolt in it. Oh, that's the symbol for electrical. Here's where you find the electrical isolation, hydraulic isolation, so on and so forth. Like any good document, when was it created? Who approved it? What version are we working on? And date. And in this particular case, we get into the specific steps on the second page on the right. Step number 1, here's your hydraulics, it's 3000 PSI. Here's the symbol. Here's how we identify it. So again, you tie that back to the picture. And in real life, this tag would be hanging off the isolation point for the hydraulic. So what I used to joke to people, this procedure should be so simple. You could grab my son, put him in front of it, he could read it, and he would be in no danger. Now, number 1, he found out I was telling people that, so I don't tell people that anymore. But that's what we're looking at with this information, is that it should be so straightforward that, again, it's a tool for someone that understands their lockout tagout training. It is not a crutch for someone that has not been trained. But if you think about it, it's a cheat sheet to lockout tagout. Yep, I've not locked out this machine in a while. I'm going to check, oh, yep, I need 3 locks, hydraulic, electrical, air. Here's how I control it. Here's how I verify I'm under control. If lockout cannot be performed, system fails, verification, tell your supervisor, and then we've got some steps, things to check before you restore energy, and we'll talk about that in our next module. Okay.
Mike, where did you see there's a couple questions
Oh,
in
I
the
do
chat
now.
at the end? What to do if a person is making controlled entry and applied locks to interlock to approach a particular robot, but there are other robots present too? Will every robot be locked and isolated?
That is an excellent question. And for that specific set of circumstances, I'd be doing a risk assessment. You raise a very good point there. At the end of the day, if I'm going to allow someone to physically enter that cell, now keep in mind, folks, we can have a variety of interlock doors. Some might just be little hatches or access doors where we can reach in but not walk in. Certainly in your circumstance, it sounds like we can open a full-size door and physically walk into that area with all those robots. What are they doing in there? What's required? And you raise a great point. Are all of the hazards controlled? What I've seen in a lot of places, if they have to enter the robot cell, they've got the teach pendant or some other kind of enabling device with them to give individual protection, because you raise another hazard when you get into a situation where somebody can walk inside the safeguarded space. Is it possible for the door to be shut behind them, right? A couple of comments ago we had, oh yeah, we put our locks on the door before we go in. Does everybody put their locks on the door? Those larger cells, can somebody be behind a piece of equipment, not be seen, and someone else closes the door and start the system? And before some of you say, hey, that would never happen, I had 2 calls on it last week alone, right? Somebody went in there to do cleaning, engineer comes by, grabs the robot teach pendant, starts moving it without even looking inside the cell. So that specific question right there about multiple robots in the same cell, absolutely do a risk assessment to make sure you're controlling all the hazards. Certainly evaluate if somebody actually needs to go in there to do that task. Ideally, you want to engineer out the need for that task, but if it's absolutely required, what are the safe conditions for entry? With that many systems, that many robots, it might very well be lockout, tagout, or some other approach to ensure that they're appropriately protected before they enter.
Great, thanks, Mike.
And
There's
there's
one
another,
follow-up on
yeah.
the placards too. Do you see that
okay.
one?
I do. Is this a placard that we develop in-house? You certainly can. I have seen a lot of different people create a lot of different placards. So if you get your hands on that CSA Z460, there's some sample placards in the appendices. What am I looking for a placard? This particular placard that I'm showing you, I actually asked some of our in-house ergonomists to take a look at it. Not because I was concerned about the technical content. I wanted to make it look easy to read, easy to use. I wanted it to look friendly. I didn't want to put too many words on it. So if you are going to create your own placard, keep that in mind. You want it to be something that somebody will use. It's not going to wind up being a landscape page with like 8 font and nobody can read it. It needs to be exactly what it needs to be, easy to use. So again, what would I encourage you to have on your placard? Number of locks required, identifying the equipment, what are the steps to take to lockout, where do I find my isolation points, how are they identified, not only the type of energy, but how much of that particular energy source is present, how to control the energy, how to verify, what to do if verification fails. So you can absolutely develop these in-house. Whatever you do, keep them as simple as you possibly can. That will encourage people to use them. Thanks for that, Jack. So takeaways from module 2,
Mike.
just keeping an eye on our time here, so I'll get us caught up here. Module 2, contents of your hazardous energy program. Take a look at those good practice documents, review it against your own program. Are there some gaps that we need to address? Make sure everyone not only knows their legislated responsibilities, but responsibilities under your local program, from management, health and safety coordinators, authorized individuals, supervisors. And I can't encourage you enough. Like, I know it's a huge job, but man, I see a lot of people starting to build these lockout placards or machine-specific instructions. It really is just another resource for somebody when they're locking out the equipment. Give them a good opportunity to check on things before they stick their hands, heads, arms into that machinery. Okay, a few extra tips before we move on to questions. Step 7, right before you restore the energy to the system, please have you checked to see if everybody else is done working on the equipment. Very rarely is it just one person working on the machine. Are the other persons done, right? How do you know they're done? Have you communicated that, hey, I'm done, I want to turn the power back on? Are they actually done their work? This requires some communication. One of the common things that I see is everybody's so excited to turn the machine back over to production, they forget to put the guards on. Or if they put the guards on, they're not secured in place. Like, I'm sorry, folks, I'm that guy. If I'm on site and I see bolts on a guard, I'll ask if it's okay for me to check the bolt. And if it's hand tight, like it's not been secured with a tool, hey, you know what? Somebody was in a rush. So if the guard's not properly secured, now we have to worry about other people getting into that machine. Was the work area actually cleaned up? Spare parts, bolts, other fasteners, grease, rags, tools. Have you cleaned up the area? I've seen a few cases where people left a tape measure inside a press, and when they started the press, the tape measure actually came shooting out of the machine just because someone didn't bother to check if the area was clear. Have we communicated our intent to restore power? Have we cleared that area? Then and only then would I suggest you take the locks off and reapply power. Lock boxes. So some of you might work in workplaces where you got a lot of people working on a piece of equipment or a process. So when should they be considered? For me, if you've got, 3, 4, 5 people and, a handful of isolation points, maybe you look to go to a lock box. Why do I suggest that? Well, take a look at a simple machine. Let's say it's got 2 isolation points, 1 electrical, 1 air. Okay, if there's 5 people working on that machine, you're going to have 5 locks hanging off the electrical and 5 locks hanging off the air. Gets a little complicated, a little complex. And if you have to throw a contractor into it, it just keeps going from there. What does the lockbox do for me? Okay, you would designate a primary authorized person. Some people call them a lockout captain, and that person will be responsible for that crew working on that system. Okay, I've seen lockout boxes used in a lot of different ways. I'm giving you a common example. So Jack is one of the 5 people that's working on that system. Jack is going to be the primary authorized person. So what he'll do is he'll attach 1 lock to the electrical, 1 lock to the air, or however many energy sources there are. He'll take the keys from those 2 locks, put them inside the lock box. He then closes the lock box and puts his personal lock to lock the box closed. Any other individual working on that line would not lock out the isolation points, but would put a single personal lock on the lock box. So what you'll have, like let's say in this picture, Jack has installed the 2 keys that you see there inside the box. He's put his lock on the outside of the box. As long as there's 1 lock on the box, you can't open it. I put my lock on the box. We both have that box locked closed. We are both in control of the keys on the inside of the box. And remember, the keys on the inside of the box is what goes to the locks on the electrical and the air. So until all the locks are off, you can't turn the power back on. So please don't think this as you're relinquishing control. I would have watched Jack put on those 2 locks. I look at those keys in the box. I'm satisfied the energy is controlled. I lock the box. Until my lock comes off, no one else can get the keys. So one other thing you'll notice about this picture, you'll see there's also a piece of paper in here. In this case, at this environment, there was a lockout permit required. So there's a lot of other people determining the conditions before you were allowed to actually start locking out. So the permit is actually inside the box, and the keys are hung inside the box with specific identifiers. That's one of the shortcomings I see with lock boxes that are sold by a number of companies on the market, is the box is literally an iron box. You can't see on the inside. So what if somebody comes along partway through the job? They don't know which keys are in the box. At least with this particular lockout box, it's got a clear front. You can actually see the keys that are on the inside. Just saw a question pop up. When is a lockout permit required? Again, I've seen it go a lot of places. For simple individual lockout, some places don't even have a lockout permit. If the environment is complex, I think a chemical facility, I think a large steel facility, you might want to consider going to a lockout permit. So really what this does is the permit would set out, okay, we're looking at this equipment. What are the hazards we expect to face? What are the steps we expect to have in place before we actually lock out and start the work? And then everybody signs on to that permit before the work begins. So usually it's for more complex work sites. I've seen people use them for everything. I've seen people only use them for big shutdowns. So the permit depends on the complexity of the work. If it's always a complex work environment, I would encourage you to consider a permit. All right. Some additional things to consider that should be part of your lockout program. Shift changes. So if maintenance work is going to go across different shifts, how are we going to hand off control of that equipment? Do we just take our locks off and go home? Or does the incoming shift meet with the outgoing shift? Here's the condition of the equipment. Locks for the folks leaving come off, locks for the folks coming in go on. Or let's say you don't have another shift. Let's say, hey, you know what? I'm going on vacation. I can't finish this work. Someone's going to have to pick it up in the morning. You don't want to leave a machine that is not repaired able to be started or used. So sometimes people will use a department lock or a supervisory lock so that when an individual leaves the work site, that the equipment is still secured. And I want to take just a minute to speak to that, because in a lot of cases, when I look and I see a person's individual lock on a machine, I have to assume that person is still there. So let's say it's an extended lockout. I'm waiting for parts. They're not going to be here for 4 days. So Mike leaves his lock on that machine. Well, now I have one less lock available to me. And again, somebody walking over might think I'm still working on that system, so I must be here. So if it's extended lockout, that equipment's going to be down for an extended time, I would suggest you use a supervisory lock, and that's a lock that might stay under the control of your maintenance manager, your plant manager, not for actually doing work, but just to secure the machine until the work can be continued, and then whoever's working on it would attach their personal locks. Abandoned locks, guess what? It's going to happen. If it's not a contractor, somebody's going to be in a rush to start their vacation. They're going to forget to take a lock off a machine. So do you have that as part of your program? Hey, Jack left his lock on a machine. Jack's on a plane to Tahiti. Jack's not going to come back to undo this lock for 2 weeks, but we need to run this machine. So what's the procedure? Who's going to check the equipment to make sure it's actually ready to run? Who's going to give the authority to remove that lock? Now, some places, what they'll do is they'll just flat out cut the lock. So please, folks, this is a heavy situation. Like if you're going to consider physically removing somebody else's lock, you need to make sure that that's not going to put anybody in danger. You need to confirm that person is not there. And I would strongly encourage you to have at least 2 people involved in this process. Hey, Mike wants to remove the lock. Charmaine concurs, and this is all documented. So when Jack comes back from vacation, he comes and he sees his lock is gone. At least there'll be some documentation to show, hey, we needed to run the machine. Mike checked it. Charmaine agreed. Lock got cut off. Again, more details in that CSA standard. Last but not least, contractor coordination. Hey, I don't have anybody on staff that can do this work. I'm going to pull in a contractor to get it done. Okay, what are their lockout practices? Hey, when you come to my site, you're going to follow the same rules as anybody on my staff, right? So here's what we expect. Coordinate with the contractors before they come up to do the work, right? Send us your lockout program. Here's our lockout program. We need to get together and make sure everybody understands what the requirements are. Don't just let a contractor come in the door and start working away. Make sure they're signed in. They understand the expectation of the work. Who's their point of contact when they get there? Hey, by the way, if I've called you to my site, I'm going to check that you're following the rules. If you're not following the rules, I'm kicking you off site, just like I would for any other employee, right? I don't want to have extra problems just because a third-party contractor comes up and just can't be bothered to follow the rules. Okay, some quick comments on training before we move into our questions. Everybody deserves some kind of exposure to lockout training. Now, individuals that are never applying locks, they should still appreciate what a lock and a tag means. It means somebody's working on the equipment. Don't mess around with the equipment. Folks that are actually doing the lockout tagout, they should have more advanced training. Here's when you would lock out. Here's the process to follow. And again, you've already heard me say how useful those machine-specific procedures can be. And folks, please make sure in your programs there is some element of practical training. What do I mean by that? I don't mean sit in front of a computer, look at a video for 5 minutes and you're trained. I mean, okay, that's good for theory. Let's go out onto the floor so you see what that looks like in real life, right? Okay, here's machine A. What are the hazards? What's the hazardous energy? How would you control them? Boom, 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 boom. Okay, you look like you know what you're doing. I'm going to have you shadow somebody for a week. And I'm just spitballing, folks. I'm not saying you got to do it for a week, but what I am meaning you to take away from this is that, hey, guess what, folks? I'm going to authorize you to follow lockout tagout. You're going to get some practical. You're going to get some people following you around. You're going to get some people that might be auditing you from time to time. Are you still following our rules? If you're not, then we're going to have to coach you up. If you're really not getting the rules, then other steps might have to be taken. So when I say skills assessments, I'm talking auditing, right? Are people actually following the rules? So again, just to recap on our takeaways, once the work is complete, clean up the area, clean up the tools. We talked about lock boxes, shift changes, abandoned lock removal, and contractors. Are those elements actually in your program? Because you're probably going to have contractors at some point. Someone is going to leave a lock behind. How do you handle it? Look at your training. Theory training in a classroom is great. What are they getting on the practical side of things? Do they understand that it looks a lot different in real life than it does in a training room? So just a quick summary of the points we've already touched on, and then I'll hand it back over to Jack. As far as legislation goes, make sure everybody understands their responsibilities. Employer, supervisor, workers. What are the tasks being done in your workplace? What are the hazards and risks associated with those tasks? Lockout, tagout might be one of the ways to reduce risk. Don't forget to look at manufacturer's instructions and consider reviewing your Z460 to get some additional insight. As far as your hazardous energy control program goes, again, CSA Z460 or that ANSI document we talked about off the top. Make sure everyone knows your workplace specific requirements. What is management responsible for? What is safety coordinator or safety manager responsible for? Again, everyone knows their responsibilities. Look at creating those generic, getting away from those generic procedures, getting to machine specific procedures. Hey, I need to lock out machine A. It's different than the steps for machine B. Those lockout placards will help us outline everything. And last slide before we get it back to Jack. Hey, once the work is complete, we talked about that, the abandoned locks, the training, all good there. Finishing point, and then Jack gets to come back online. Where can you go for more support? Well, get to know your account manager, folks, at WSPS. All you got to do is call into that number, tell them what your postal code is, and they'll tell you exactly who your account manager is. Best way to get additional insight as to what WSPS can do for you. Call that account manager, figure out who's responsible for your site, and they can have those conversations. Other resources on our website, we do have a lockout tagout training guide. Now that is meant for folks that might be doing lockout training internally. It speaks to how to prepare for the training, how to get used to the equipment, how to make sure your training sticks with adult learners. We also have a series on hazard control for lockout tagout. It's available in multiple languages, free off the website. English, Tagalog, Spanish, Punjabi, French, Mandarin are the languages it's available in. And we have a number of free safety videos. They're 2 to 3 minutes each. Between that lockout training guide, those hazard control series, and the safety tip videos, you've got everything that I just presented to you in the last hour and a bit. And of course, if you need additional support, training and consulting, work with your account manager. You can see what other services are available. And last but not least, before I turn it back to Jack, please note that we are running another safety connection for supervisory responsibilities in the steel industry. That's going to be on September 4th. You would register it the exact same way you registered for this session. Go to the website, plop in your name, free to attend. Jack, I went a tiny bit long, but right back to you.
Oh, great job, Mike. Thanks for that thorough presentation. And I see Don's back on the camera as well. So this is, we have about 10 minutes left for additional questions. Thank you for the questions that have come through so far. Mike, there's one there about who, and maybe Don, you could pop in as well. Who is responsible for the application of the lockout tagout program? Would it be the safety officer or would it be the supervisor?
I'll throw a comment in there and then I'll let everybody hear Don's voice instead of mine for a couple of minutes. For me, again, the application of that program, I would take it back. I would say it's the employer's responsibility to make sure that that program is in place. As far as the execution goes, I could see the safety officer supporting with auditing, creating that program. I could see a supervisor doing the same thing. It depends how you lay it out in your program specifically. So with that, I'll pass it over to Don.
Yeah, I think, Mike, you said it really well. It's the employer's ultimate responsibility, but it's also the supervisor, whether it's the maintenance supervisor or the line supervisor, the foreman, or the lead hand. If the employer is employing them as a supervisor, they have some duty and responsibility. And you pretty well spoke about that at the very beginning of the presentation about supervisors on the line or in the workplace. They need the same level of training. So when their workers are performing lockout, tagout, the supervisor can ensure, one, they're doing it properly, and those 7 steps are being carried out also.
Great. There's just a comment there about from Charmaine. Just I think that there may be some organizations that block comments in Teams. So if you do have a question and it hasn't been addressed and you're not able to get a comment through the chat, Mike gave the phone number, but you can always go to our website, wsps.ca, and click on Contact Us, and just ask to be put in touch with an account manager to answer your question specifically around these issues. And you may even be referred directly to Mike in that case.
And Jack, if I could say something.
Please do. Thanks, Don.
When our inspectors do come out to the workplace to do an investigation, or there's been an event or an incident involving lockout or tagout, what we have found is that we never make it to step 7. Somewhere between step 1 and step 6, the lockout tagout procedure wasn't followed. And those are pretty, I'm not going to say basic steps, but those are 7 questions that you can expect one of our inspectors to be asking the employer. Right from the very first one of preparing it. Was the machine shut down? Were workers provided information, instruction, and training on those? So if those 7 steps are being followed and workers have been provided the appropriate training, then you'll never see an inspector coming in to deal with an incident or an event. And earlier in the chat, and Mikey did a really good job of answering it, is that should they be saving their lockout tags or their lockout logs? I think it's a good idea. It demonstrates due diligence on the part of the employer. And when we do our investigations, we collect all the information, whether it's bad information or good information. And if the employer has a lockout program and they can demonstrate to us that they do lock out all the time or for the jobs that require it, and here's our tags, here's our log, that goes in, it really goes in favor of the employer because they are demonstrating due diligence. And then it can also come back to say that if there was a worker injured and that worker didn't follow on the lockout procedures, but there's been lockout, that worker has done lockout, tagout a number of times, then we'll focus our attention on that worker perhaps.
Thanks, Don. That's great information. Quite a question just popped up. If tags are to be stored, for how long should they be stored? What duration would you recommend?
The legislation doesn't speak to it, but we would leave it up to the employer. Do we expect 5 years of lockout tags? Probably not. If there is a complex lockout procedures, you may want to save those lockout tags for a little bit longer than normal. You know, there's a lot of reference to 1 year within the act. You could keep them for 1 year. If you don't save the tags, it's fine. What we'll do is the inspector will just ask the workers that do perform lockout, tagout, you know, have you been provided information, instruction, and training on it? Have you done it before? How was the training delivered? Was it done online? Was there a practical part? You know, you can get the training in class. Not everybody may understand it, but when you do the practical portion of physically going out, then that training sort of kicks in and they have a better understanding.
Exactly.
Great.
If I could just add to that, Jack, if you
please, thank you.
Talk about storage of tags, for example, the standard doesn't get into anything quite that specific. So to Don's point, establish your protocol. My advice would be as long as you can, because you never know. But sorry, Jack, I just saw one pop up in the chat there.
That's good. It's the follow-up question. Do you think saving the permit serves the same purpose as saving the tags? More
documentation you got, the better, if you ask me. Usually when I have seen people saving the tags, there's a permit that goes along with it. I have also seen people just save the tags and archive them accordingly. Again, I would establish your own internal policy. Just keep in mind that, to Don's point, there might be questions asked one day, and that could go a long way to demonstrating that you've had good practices in place for years.
Great. Maybe I'll just finish off with one question kind of related to that first poll you put up, Mike, about asking the participants, you know, how would you evaluate your current lockout tagout program? What are some of the common mistakes for both you and Don? What are the most common mistakes that you see around lockout tagout?
Oh, well, I touched on a lot of them as we went through the session today.
Sure.
Is, failing to identify the hazards associated with the machinery, failing to understand how the machine performs when energy sources are removed, not applying the locks and tags correctly. That's a common one. And sometimes just really thinking that you can do the work without controlling the hazardous energy. It's like, oh, I've seen so and so do it. I'm going to do it without lockout too. So that's typically what I see. And then I did see Charmaine popped in there. Fail to train, and certainly failure to evaluate skills does lead to a lot of problems.
Don, do you agree with that list that Mike gave?
Yeah.
Anything else to add?
I agree with Mike, and he's absolutely right. And what we also see is that sometimes the maintenance supervisor, who's in charge of a number of maintenance people, they're the ones that never attend the lockout tagout training. In fact, most of them don't even attend any of the training. The employer just assumes that they know everything, and when those maintenance workers aren't present in the workplace, it's the maintenance supervisor going to go over and try to do lockout tagout, and has never received the training, especially specific to that piece of equipment.
Great. Well, that takes us right to 12 o'clock. Gentlemen, thank you very much for the presentation today. Mike and Don, thank you for being here and helping us with the questions and setting some context. There was a note in the Safety Connect from our Safety Connection coordinator that all attendees will receive a follow-up email with resources from the session. And if you would like to speak to one of the WSPS staff about any concerns around lockout tagout, you can certainly respond to that email as well to get in touch with us. So thanks again for joining us today. Wish you an excellent day for the afternoon. Thank you.
Thank you.